Hey everybody, thanks for joining. It's just about noon here, so I figure we'll get started. This is part 2 of our SOLIDWORKS electrical automotive harnessing webinar. Try to make this apply to as many people as possible. Obviously, the automotive harnessing world is not huge, but maybe industrial harnessing or our aerospace and defense friends can get something out of it. So I'm going to spend the first couple of minutes here while people are catching up, logging on to go, recap what we talked about the first time, where we covered the 2D schematic portion, and blow through a couple of these slides just in case anybody missed it. And then we've got some very cool 3D routed geometry, and then it kind of trying to answer the question of, great, we've got geometry routed, what do we do with it? So just to blow through these really quickly, our electronics versus electrical definitions here. This goes back to what are we talking about with SOLIDWORKS Electrical with this product. Electronics would be our PCBs, traces, layers, through-hole components, surface mount components. Those are all PCB terms. With SOLIDWORKS Electrical, it's really a systems level tool. So we're going from the board up, as the way I like to put it. So from wires to components to systems, sub-assemblies, and then our top-level assembly. So this is what SOLIDWORKS is typically known for, would be our components. Everyone designs their mechanicals in 3D. We then also have these kind of electrical and electromechanical components, so it would be really great to be able to represent all of those. So we've got our, everything that routes within a cabinet, great. We also have our devices that live outside the cabinet, great. This is what you've probably seen from SOLIDWORKS Electrical in the past. If you've seen any SOLIDWORKS Electrical demos or marketing material, it's mostly cabinet-based. But we can also do harnesses, and this is an automotive engine harness, not one of mine, but a good representative idea of what we're talking about here, where it's connector to connector. We might wire directly to components, but it's rare. So we need a program, we need some software tools that will allow us to put all the pertinent information in and also get it out in a form that actually helps us make this harness. And that's kind of what SOLIDWORKS is all about. It's all about manufacturing information, what's actually going to help industry. This isn't art software. We're not rendering just to get a picture, although the pictures do look really nice. So this is kind of our end goal. It's something like this. This is a very simple representative copy of a, point-to-point harness. We got a couple of connectors on here. We got some colors. We got some wire information, and then, wire length. So eventually, the way that these harnesses are built, we sometimes go to a what we call a manufacturing flattened document, where it's a one-to-one scale document to create a pegboard like this to actually manufacture these. So I think that's it for. Oh man, I went right to my end part here. I got a couple of pictures to show you in my SOLIDWORKS electrical document. So this is my document here. You may have seen this on our Wednesday webinar. We have a single line document. I'm just going to blow through these really quickly here. Single line document. I've separated the power and the engine control documents. You'll notice that these are pictures of the actual connectors. These are, we have part numbers. We have what I'm actually calling these. I tend to use names that actually make sense for these. I don't just use the part number, since we get a lot of these repeat part numbers and harnesses. So this is a pared down, representation. We also have our power multi-line documents. So these are individual, one line per wire, and our engine control multi-line document. So couple of things that I pointed out in our Wednesday webinar, things that are pretty cool about this. You'll notice Infinity C1, Infinity C2, these are the same two connectors. These are the connectors that connect to the engine control module, but I'm representing them in multiple different places for the sake of making things easy to look at, right? So I've got all of my, my driver side coil packs here, all of my passenger side coil packs here, and where they connect to the Infinity connectors. This is, if you're troubleshooting or building, actually this is more of a troubleshooting thing. If you're building it, you'd probably want all of them, but this is what people tend to want to look at, is one subsystem on a page. Well, I can represent pins here, just the pins that I'd like in order. I can also, if we look over here on the injector side, I can represent them out of order, and this is all done through a wizard. So I just go in here, select which pins I'd like to put on a page, and place them down. select the wire the wire style that represents the individual wire I'm using. So this is a really handy, so I basically separated out coil packs, injectors, sensors, just a little representative version of some of the ways to use our connector tool in our multi-line. And this really helps because we need point-to-point wiring information in order to route these wires. So just as far as the background, as far as what we need to route, we can do it with something like this, with a single line document. We can actually go in here, define a cable. So this is my my crank angle sensor. It's a Hall effect sensor, not necessarily high speed. You know, gas turbine guys are reading hundreds of thousands of RPM. We're reading a couple thousand RPM. But this is really what helps the engine computer determine all of the subsequent events. So we really need an accurate signal here. So we run a shielded mil-spec cable here, and you can actually see that each of these conductors is fully defined. So I can actually route off of just this single line document. I did not define this crank angle sensor over here on our multi-line document. So I'm trying to show, you know, you can do one or the other or both. In the example of, say, our cam angle sensor or our map sensor, if I hop back over here to our single line, you can see here that these three wires are represented for the cam angle sensor. I did not run a separate cable. These are just wires. So these are represented as what's called wires without cable. Same deal. It's just showing the association between single line and multi-line. So a lot of, if your end goal is to route geometry, I use a combination of both, single line and multi-line, whichever's easier, whichever's less work for me. You know, I'm not lazy. I'm just pragmatic. So these are all of my documents. I've got 4 documents here. Some of it's repetition, one to the other. I then in SolidWorks Electrical create what's called a SolidWorks cabinet layout. They call it a cabinet layout. Basically, I'm creating a 3D assembly for this model. Now, workflow-wise, I don't want to recreate the entire mechanical assembly of whatever I'm using. I just want to use it to route. So generally I will insert my previous top level, or insert my, if I'm only routing using a subassembly, I will insert that subassembly into my new SolidWorks Electrical created assembly. So I'll kind of show a little bit about that. But first, what are we actually routing on? So I've got a race car, and I'm going to show up a couple of pictures here. It's a Mazda RX-7. It's got a supercharged V8 engine, bunch of goodies. There it is, and you can see the harness here is I did it in a white loom, so it would actually show up on the white car. Didn't work; it gets super dirty. But you can see a little bit of the harness here. This is the exact same harness, just done in black. This was one of the ones that I made. So this is a reasonably complicated engine harness. A couple hundred wires. I don't remember how many connectors. You know, less than 50. But you've got construction of this is key, and of course documentation is key if somebody wants to make this and then get paid for it. So to get this data into the computer, we 3D scanned the car. So I did it in sections because it turns out these 3D scan files actually are very large, and this is something that GoEngineer does in case anybody's, you know, asking about this. What we're holding here is what's called a HandyScan 700. It's made by Creaform. It is a fantastic reverse engineering tool. There is nothing better than this when you couple it with the software that helps you get this data into SolidWorks. So what you're looking at here is the SolidWorks data for the outside surfaces and the inside tube structure all together. And so I took this, you know, this is a photo view 360 rendering. So we're going to hop in here to the actual model, which is my SolidWorks assembly. Give everybody a second to pick up their jaws from the floor because this looks so cool. I get excited about this stuff. So we have the outside surfaces. We also have some of the engine components. This is something I use to develop the front cooling package, where we have to decide how much room there is for things like intercooler, radiator, and all that. So I'm going to go in here and I'm just going to hide the body components. But you can see that this is my full top level assembly. This is real deal. Everything's in here for the, you know, as far as the surfaces, as far as the engine components. This is what I use to route, and the routing engine, everyone always asks me, okay, great, I saw the demo, it looks great on the video, how does it actually work? Well, it actually works pretty well. So we're able to do things like use our real top level. So I want to take a couple of minutes here before we go into what goes into the actual routing and discuss workflow. This is the questions that we always get when people are interested in the software, but they're not quite sure if it's going to work for them. What do you have to do to be able to use this stuff in 3D? So I'm going to use one of these injector connectors as an example. So this is a Delphi connector. We can see here that it's a reasonably detailed model. I'll give you a hint. I did not draw that. So I have a part number for it. I go to the all-trusting internet here, and I download a 3D model for it. So I'm going to show you what I had to do to this 3D model in order to use it. You'll see that this is imported geometry. I did not draw this. I imported the IGES file from the manufacturer. You'll notice if you've used electrical routing before, you'll notice that these look like route points, but they've got some funny names on them. In what's called SOLIDWORKS electrical routing, which I call vanilla routing or plain old routing or dumb routing, we would have things called C.1, C.2 and such. With SOLIDWORKS electrical, in order for the 2D electrical portion to be able to pick up the data in these 3D parts, it has a special naming convention, and you're not expected to know this. So I'm going to go ahead and delete these. Well, actually, I'll just run through the wizard here. So we have under our Tools menu, SOLIDWORKS Electrical Component Wizard. So this wizard is what gives you the ability to easily give electrical intelligence to your existing 3D parts. I don't want anyone to think that I had to create these parts separately or new or anything like that in order to use them for electrical routing. So you'll see a DIN rail component here. I can define the left, right, top, bottom. Not concerned with any of that. Here we have some built-in mate references. So one of them is for a 35 mil DIN rail, one of them is for things that mount to the back of an enclosure, one of them is for things that mount to the front of an enclosure. Well, that's not how I'm going to do my mate references for this, so I don't really care about any of these either. The last one is create connection point or create connection point by reference. This is where we can either, if we know the circuit layout of these parts, and I'll flash back to SOLIDWORKS Electrical 2D here so we can actually see what I'm talking about. So this is my, my injector. If I double click it, I get its component properties. I hop in here to my manufacturer part information, and I can see that this is a Delphi 15419715. Great. My description, it's a US car fuel injector connector. It's GT150 series, two-way. Fantastic. This is what's important. In the database of the software, it says I have two circuits. They are of type auxiliary female pin, and each of these circuits, you can see in this window down below, has a single terminal labeled Alpha and Bravo. We need to associate that terminal information in the database to some 3D information on the part in order for the software to be able to automatically route anything. And I'm all about automatic, right? So I'm going to hop over here, and I'm going to say create connection point by reference. And what this does is it gives us the ability to select a manufacturer part number before we start assigning circuit information to points. And this makes sure that you get it right. And sometimes your 3D file will actually have an embossed or debossed, 1, 2, 3, 4, A, B, C, D, and what have you. In this case, I had to look at the actual drawing to find out which one of these was which. So these are bold. These are basically telling me, hey, you've already done this. But in essence, all you have to do is select a point, or if you don't have a point already on a sketch, you can just click and it'll say, would you like to create a new sketch and create a new point? And what it'll do is it'll create that connection point on the point that you select with the direction of the connection point where the wire routes normal to your sketch plane. So that's all I did. I clicked the center here. I was able to use one of the that's a non-planar face. Thank you. I was able to basically pull the center point from the geometry and say, okay, that's a wire goes there, hit the green check, I'm done. Now the next part would be this cable connection point. And the cable connection point, I should have a picture of it here to pull up, but I don't. this is where the wire splits. So you can picture if you had a cable, the cable has some insulation on it. The insulation ends and the two conductors come out of it. That's the cable connection point. So it's telling me you already have one. Basically, I have one floating out here in space. For something like this, where these two connectors are, you know, 1/4 inch apart, I generally use 3/4 inch, but that's just my preference from a lot of experience with twisted pair cables. So that's it. I add some connection points. You can add an EW cable point if you'd like, and you can see that these are just regular routing points. They just have special names. So you can still edit these if you wanted it to go the other direction, you know, reverse direction and route through the front of the connector. You can, you know, do that right in here, just like you could with regular electrical routing. So this is where SOLIDWORKS Electrical 3D and our typical electrical routing cross a little bit. So I'm going to leave this part as soon as my SOLIDWORKS catches up with me here and come back to my assembly. So you can see that I've got, you can imagine that I've done this for all of my connectors. And it's not like you have to do this for each individual connector in the assembly. You just have to do it for each connector you use. So I think I used, I don't know, 7 different types of connectors. Now, over here on the left, this is the electrical manager. These two icons over on the left and the right are what tell you that your SOLIDWORKS Electrical 3D plugin is active. And if you can see a project name here, and you can see your documents, so I can actually look at my SOLIDWORKS electrical documents from within SOLIDWORKS Electrical 3D, from within SOLIDWORKS. This is showing the communication. Now, on the left, this SOLIDWORKS Electrical Manager contains my component tree, and you can see my component tree is split into locations. And so this is really analogous to your SOLIDWORKS feature tree being split into your top-level assembly and your subassembly. You can imagine that I have a subassembly for the cabin components, a subassembly for the engine bay components, and a subassembly for the rear components. Within my engine bay, I have all of these individual components. So looks like I've got 8 coil packs, I've got 8 injectors. These are SOLIDWORKS electrical components. These are not SOLIDWORKS components. Contained within the electrical component is a link to a 3D part file. So you can see that it looks like the SOLIDWORKS assembly icon. If I had placed all these one at a time into my project, I can just say a right click and insert. But if these were already placed, a lot of my customers have already started doing some electrical routing, maybe, you know, or they've started having some of their connectors in their drawings just so people can see where the connectors attach. All I would have to do is a right-click associate. So here this is already associated, so I can disassociate it. But if this was not associated, you would say associate, click that, hit the green check. It is not a big deal to add the electrical intelligence to your SOLIDWORKS parts. So that's if there's one thing to take away here, it's that it's a couple of steps. It's all done through wizards. No big deal. So I want to show you around a little bit. So we have in this assembly, you can see that, you know, I'm on a laptop here. This is still pretty snappy, even though, well, you're watching through a webinar, so maybe it's not. But performance is still very good, even though I have all of these route components. Every single pin is detailed. So inside my cabin, for example, I have some of these switches. And if we wanted to see which switch this is, you can click it. And in my electrical tree, this is that link between this part number, Honeywell 1NT1, and what I'm calling it in my electrical document, which is start switch. So there's my starter. Looks like that's my ignition switch here, and then I've got a fuel pump switch next to it. So this is that association. Now for these, you can see these actually use 1/4 inch quick connects, but I did not use them because I just wanted to show routing to a connector. I have said route wires, and I've got white wire, black wire coming out of each of these, and you can see that it routes over down here. Oops, sorry about that if I'm making anyone dizzy. It routes down here to my RacePack SmartWire PDM, and it's beautiful. Routes right in there, right to the connector. And again, I didn't draw these connectors, if you would believe that. I downloaded these. So you mate them in 3D space, you know, workflow-wise. We assign our pin information once. We bring them in through a right-click menu in our electrical manager over here on the left. So that's, you know, we're bringing them in one at a time. We mate them in space, so that's usually if we're talking to electrical people, that's where they get hung up is, I don't know how to use SOLIDWORKS, but I think any SOLIDWORKS mechanical people would agree mating things in 3D space to an assembly that already exists, not the hardest thing in the world. And then for these individual wires, these are just individual white wires. You can see I've got the grounds going over here to a combined ring terminal. For individual wires, I would go to my electrical 3D tab. Oops, need to exit this assembly here. Go to my electrical 3D tab, and I would say route wires. And I can do it for all components or for some components. So if I just wanted to route, hey, route whatever wires are involved with those three, I can just route those. And that's how we kind of manage the workflow of, I have a huge assembly. I don't want to sit here for 10 minutes while it tries to route all of it. So I could just do these three. And if I want to get a look at where it's going to route, I can hit draw graph. So what it's going to do is it's going to read the connection points, and it's going to look for any EW paths. So these are these paths that SOLIDWORKS Electrical uses in order to know where to route these wires. So again, I'm trying to give everyone an idea of the workflow. You can see that there's some teal wires running around here that are some teal lines. These are EW paths. These are paths that that SOLIDWORKS has come up with or that I've helped it along with. So I want to show you those. Full disclosure, there was, some 3D sketching that went on before we came in here. So you can see this one. This is the EW path that it's referencing in my top level. It basically, you can see the dotted lines where it comes around. I gave SOLIDWORKS a little 3D sketch saying, try to route your wires over here. And that's why, oops, wrong way. I don't know if you can see that very well over the webinar, but we've got some dotted lines here that just show it's orthogonal, it's only lines, nothing crazy, but that's giving SOLIDWORKS an idea of where I want to route. Now, my intake manifold, if I open this part or isolate this part, my intake manifold has a 3D sketch associated with it as well. And the idea is that when you're creating geometry that you would like SOLIDWORKS Electrical to automatically route with, things like ducts or, hey, whenever we use this cabinet, we always route down the left side or whatever it is, it's not a big deal to create a sketch that represents the center line of where your route should be. And so I liken this to, if we're creating a cabinet, you're going to run some Panduit. Well, that Panduit will have an EW path running down the center. That way, I don't have to manually tell SOLIDWORKS each time I'd like to use that Panduit where I'd like to route. So with my intake manifold, I said, well, hey, I usually have some injectors coming out of these holes here. I have some coil packs over here on the side. So give me a route path, I don't know what I did, 3 inches out from the corners there. And I'll show you in a second. It actually used that and did a pretty good job. We also have one, you can see this teal up here for these for my headlights. So I'm going to hide sketches so that the sketches go away and you just see the wires. Similarly to, let's turn off my route points, a little too much text in here. So similarly to these white and black wires for these switches, I ran some thicker wires for my headlights. So these are a couple of headlights hanging out here in space. You can see they've got a red and a black wire, beautiful splines here. I didn't route those manually. I just said, let's go back to my electrical menu here. I just said, hey, here's my headlight, right? And over here, here's my ground for that headlight. It's this ring terminal down here. SOLIDWORKS Electrical did the rest. It read my route path where I had told it, kind of route along this way and along this way. And it said, instead of running these wires through the middle of your engine, I'm going to run them down here, along this, up to here. They're going to meet. They're going to come through this firewall hole. And it looks like they've missed, a little bit right here. So maybe I want to bring those actually through that hole there. Well, I've created this part to be what's called a clip. This is an electrical routing thing. It has a clip axis, so I'll show you that right here. Clip axis. And so if I want to edit this route, all I have to do is click it in space, say edit route, and you can see here's the driving sketch for both of those red wires. I come into my regular electrical, I say route through clip, it says which route would you like to use, I say this one, and then I click that clip axis, and now I can do the same thing for, oops, we need to go route through clip again, and click this one and say route through clip. So I'm basically saying it's wanting to click the actual spline there and not the clip itself. There we go, hit the green check, and now if I exit this route sketch, you'll see that my red wires route cleanly through the middle of that. So it's very easy to edit this stuff, except now it's decided that I want to route through my engine. So this is the whole idea of we put in some information up front, we give it some circuit information, we have some manufacturer part information, we probably have that stuff already. It's just a matter of someone putting it into SOLIDWORKS Electrical. And then we have it automatically generate some routes and do some editing. So we might have to edit these routes, but it's a lot easier than trying to route this stuff manually. So that's kind of the story for wires. Now, a lot of people are not here because I was able to route some wires. You're here because you want to talk about harnesses. So I'm going to hop back to SOLIDWORKS Electrical for a second, and I'm going to go to my project tab, harnesses. So I have created two harnesses. One of these I didn't put anything in. My chassis harness is empty. My engine harness has a bunch of stuff. So we have some components. These are all of my connectors. We also have some line diagram cables. So this is where we're representing things in a line diagram. We have some wires. These are my actual wire numbers for all of the wires that connect what's in the harness. And we have that single mil-spec cable that we talked about. Now, a harness is not shown anywhere on the document, and that's kind of a hard thing for some people to understand. They want to say, hey, well, I don't know what's part of that harness and what's not. And the only way I can really double check is if I click, say, one of these injector wires, and I come up here to my properties, I can edit the properties for that equipotential, for that individual wire, for that wire style, and I can also see that it's inside a harness. So I can see that it's inside engine harness. So all of these components, the wires, the connectors, I've got a couple of splices in here. These are all part of that harness. And the reason why we do that is so that once we come back to SOLIDWORKS, instead of saying route wires, we can say route harness. And this actually goes pretty fast, but not quite fast enough to do live here on a webinar when we only have a couple of minutes left. So I would say selected harness, I would say my engine harness, hit select, and hit route. Now, I'm going to do an isolate on this. This would be a good time to point out, once you actually create these routes, you can see them down here in my feature tree. It's an EWA, ElectWorks assembly, and it's a 16-2, that's my wire style. And I also have 22.0, that's my black. I have 22.9, that's my white. 16.2, that's my black. I have this harness, and because I used imported parts for a couple of these connectors, I have some stupid imported geometry, you know, what's wrong? It just says error found. So anyway, don't take that to mean there's anything wrong with this harness assembly, but I am using imported parts. So inside this harness that was automatically created when I said route harness, let's do an isolate here so you can see it. This is what this is the moneymaker, right? I mean, this is what you want. So a couple of these I did not fully define in 2D. So I've got an intake air temp sensor out here and a drive-by-wire throttle that's not connected. But this is my harness in 3D. And so that looks like I didn't grab that cable either. So some people will say, some people notice that it has orthogonal edges here. That's just an artifact of the math that's going into deciding how thick these sections are. And we can make these sections tangent. So that's a common thing. People say, well, you know, it routed wires beautifully, but once I route harnesses, you know, it looks terrible. But it's actually doing the math. It's saying, hey, inside this section with these wires, what's the overall thickness? And then it creates the geometry of that overall thickness. This allows you to do some very cool stuff. You can see there's a couple of wires that didn't get routed over here on these guys. But it does some very cool stuff because we know the actual diameter of the harness at this point, I can do things like intelligently choose my harness breakout tees. I can intelligently choose coverings. If we use something like electrical tape, it will actually calculate using the twist method, how much coverage that you specify. It'll actually calculate the linear distance of electrical tape that you need. If we're using something like heat shrink loom, we can have it calculate exactly how much of each size loom we need. So if this is, a 1/5 of an inch, it'll say, hey, you need a 1/4 inch section at least this long. As soon as it goes above 1/4 inch, it'll say, hey, you need a 3/8 section at least this long. So I haven't quite gotten it to where it'll intelligently choose breakouts. So in some harnesses we would use a three-way T here where it'll have, maybe 1/4 inch one side, 1/4 inch this side, 1/8 inch this side. Doesn't go as far as to automatically choose those part numbers, but I am playing around with the design table for that. So that's why these sections look like this. These are gray cylinders. They are still routed off of splines, but those splines have orthogonal edges until you make them tangent. So I'll show you what that looks like right here. If we hop down here to, I apologize if anyone gets dizzy here. If I right-click my harness, so here's my harness. If I say Edit Route, we're going to see the driving spline, and you just select these two sections and say Tangent. And you can do that anywhere you like. So a lot of times, as soon as we route it, and again, this is the idea of, because it routed automatically, I don't mind spending a couple of minutes to make it look pretty. And you can sit here and move these splines and make it look any way that you want it to look, and it auto updates. So it's updating live, and you can now see that we've got some nice tangent curves here that drive that harness. So the idea is we're putting this information in. A lot of it we already have. We're then having it automatically route this harness. We do a little bit of editing to the geometry to get it how we look, and then like I said, the moneymaker is we come in here and we say flatten route. So it's going to say, do you want to save it? I'm going to say, yeah, go ahead, let's save it. It's going to save to that same directory. I already had one, overwrite. Thank you very much. And the reason why we save it is so that we can reuse this harness assembly outside of the original assembly. So very cool. So here's my harness. It's doing a nice isolate here. I've got my ECU plugs down here. I've got my my sensors and everything up here. I generally turn off component origins and route points here because I don't need to see those. And here are my options for flattening. And anyone that's done regular electrical routing has probably seen these. We have an annotation flatten, which is not to scale. We have a manufacturing flatten that is to scale. We have options to flatten the clips as well. I don't have any clips in here except for that one at the firewall, so let's grab that. And we can either use drawing connector blocks, which are linked DWGs to our parts, or we can display the 3D connectors. I don't know anybody that doesn't like 3D stuff, so we'll display 3D connectors. And then here, I have options for creating this drawing. So I'm going to put a D-size sheet. It's nice and big. I do want the electrical BOM. This is going to have all of my components, as far as these connectors, as well as every individual wire with its length. Cut list has some similar data, but it is a little bit different, so we call this a circuit summary. That has our from to data. And then a connector table is going to be at each connector. It's going to give us a table of which pins connect to which. This makes for a very busy drawing, but I do want to show it to you. So all I do, I hit the green check here, and this is a certain number of seconds thing, not a certain number of minutes thing, to flatten this out, create this flattened configuration. And it's going to put this on a drawing for us, and then add all these tables automatically. So I had customers that would that make a lot of harnesses, and some of these were aerospace and defense customers. I mean, these are intelligent people. They would be in here using either SOLIDWORKS drawing tools or something like AutoCAD to literally create this drawing manually. And as soon as something changes, you would have to go in and make all those changes manually. I can't imagine. Once I saw this, this looks like a heap of confusion, but once you realize what all these tables are, this is the connector table for my 73-pin connector. So maybe I don't need that guy. But here are some of my other connector tables for these individual connectors. I'm going to zoom in so you can see that See, it's highlighting that connector and then showing me it's a 4-pin connector and it's routed a couple of these wires. Not every connector is fully populated. So here we've got, this is our electrical BOM. We only use 3 colors of wire for this, which is why you only see 3 lengths down here. So I'll show you what that means in a second here. Let me hop in here. So this is the part where everyone says, well, oh, that's really messy. And you just, yeah, we're coming in here and we have to kind of drag things out to make it look how we want. So that's a ring terminal. I don't need that. Here we got, connector for another ring terminal. Don't need that guy either. So you can see that this is one of my splices. Don't need that. And so you kind of clean this drawing up manually. This is an injector wire and injector wire. And these are ballooned and tagged for length. So I have it set to tag down to the 1,000th. This section, we were talking about, these sections of, how much covering do I need and all that. You can see SOLIDWORKS Electrical does understand exactly how thick this section is. It has ballooned, saying you have, 2 wire 9s and 1 wire 8 in here. And it said it's exactly 12, 12 and 3/8 long. So we can come over here. You can see that this is kind of the same for the whole thing. Now over here you have that circuit summary that we talked about. So this is everything you need. Some people would call this their net list. This is everything you need to build this harness. From SmartWire B 2515, this is basically the internal IDs of these connectors. We are running conductor 14, so wire 14. It is red. It is exactly 36.744 inches long. These are all of the individual wires that you would need to recreate this harness. Over here, this is our actual bill of materials, and this is, you've probably heard the term SOLIDWORKS Electrical electromechanical BOM, combined BOM. Oh my gosh, it's wonderful. Well, in a simple thing like a harness, this is that combined BOM. So we have some Delphi connectors, we have a couple of ring terminals, we have a quantity over here, and then we have these 3 wire types. So these are wire styles, and we can replace these internal IDs with their actual names if you'd like. And these are the exact lengths of how much wire was used in this harness. So that is the part where we can instantly tell based on this table, and of course, just like anything else, we can go out to Excel with this, we can go out to XML with this, you can do whatever you'd like with this table. But this is how we would get your live pricing. So as it's routed right now, this is exactly how much wire we need. These are exactly how many parts are in it. This is what it's going to cost. If we were going to build it, these are the exact lengths. Hey, shop floor guy or girl, go out and cut, this much of each of these wires. We can have it automatically add a certain percentage or a certain amount. So if you like to cut everything 1 inch long, or if you like to cut everything 5% long, you can have that math in there as well. This is what you use to build the actual harness. So pretty cool. We hop back to electrical. On Wednesday we talked about reports. So under project reports, you can see that I've got some reports that I had done here. I actually don't need PLC I/O, but we got wire tags, we got bill of materials, we got list of wires by line style, list of cables, and a drawings list. If I hit generate drawings, I don't have to go delete them. I just say, hey, regenerate those because I added some information. It's polling the database now from 3D to add information into the 2D database and into these reports. So when I go to my list of wires now, all of these wires that had lengths of 0, I didn't route my fuel pump wire, my mistake. So we got some 16 gauge wire that runs back there. We got some, these are for the headlights, right? So one would be quite a bit shorter than the other. We have some wire that runs out to the splices. Let's go to the next page here. Here's some injector wires. These are injector power wires. So these are actual lengths for this. This is our white wire that went to those switches. These are the actual lengths of all these. And at the end of each section, so all of my 22 gauge black wire, right? They give you the actual total routed length. So that 184.42 probably matches up to one of these values, except we've added some slop here. So 184.42 became 184.794 because of some internal stub length of those pins. So that's the whole loop. We put some information into electrical 2D, either through our line diagrams or through our multi-line, or both. We associate that information to, let's control tab back to our drawing here. We associate that information back to our 3D parts so that we can route, and we're routing off of our existing SOLIDWORKS 3D geometry. So we're not having to create new assemblies. I already had this, this front engine bay assembly. So I was able to use it in order to route this stuff. All I had to do was mate these connectors where they needed to go. And you don't even really need the assembly to do that. A lot of people say, well, I have a, I have a kind of a pegboard of how this needs to go. Okay, great. Mate it like your pegboard, and then hit route, and it'll route automatically. And the automatic route is pretty good. So there might be some tweaking that you need to do. Hey, your spline radius was too small, or hey, I want this black wire really needs to get zip tied up here to this pole. So edit this route. Well, you actually go click it in 3D and say edit route. I mean, it really is more straightforward than most people think it is. And so once they get into it, we do a little training, and this is a single day for 3D training, and you're able to actually get useful information out. There's not a whole lot of other ways to get the routes out for these when you're trying to make, something like this. And so you can lay it over an actual engine, you can measure with string, all the things that people do for all their harnesses. But I will say, having done all of it, using the geometry in 3D is the most straightforward and gives you the best idea right away of how this is going to work. So I did try to compact all this information to trim some things out so that I can show all this in 2 30-minute sessions. I appreciate everyone making it through this. I'm sure that there are going to be some questions about how I did it and what we did. So now would be a great time to ask those. I see a couple right here. Let me scroll here. We do. Somebody asked if we have Wednesday's webinar for the 2D section. I did record it. It should be submitted on our side. Should be up hopefully end of the day today, if not early next week. And what I hope that we'll be able to do is email out the links for both of those to everyone who registered, because we did have some people that registered but weren't able to attend. So that's my plan for that, Hugo. Thank you. So let's see, we have any other questions here? I've gotten confirmation from my wonderful Dina here that they will go out. The links for those videos will go out to everyone that registered. I've sectioned out a little bit more time after the webinar here, so if you guys do have any questions of individual parts, or want to see some part of this workflow, I'm happy to spend a couple of minutes to do it. Let's see, I got a question about, is there a SOLIDWORKS electrical for students? So electrical is part of our research licenses, but I'm not sure. I think we have a special student edition for it. So that would be something to ask whoever you get your student editions from. So usually it's your educational institution. They've talked about changing it in 2016, but I think our 2014-2015 student edition had electrical separately. So I know it's out there, but I don't know exactly which package it's in. So I would say to ask whoever you get your student editions from. Hugo asked another great question. Is there a panel design webinar? We've got a bunch of panel design webinars. The best place to check would be GoEngineer's knowledge base, kb.goengineer.com. But if you shoot me an email, oh yeah, that was going to be my other thing here. Is I didn't have that last slide. My email address, jjordan@goengineer.com. Let me hop up here and get that back on the screen here. Thank you very much, PowerPoint. So yeah, I didn't show a whole bunch of this, but my email address down there on the left, jjordan@goengineer.com. I'm happy to point anyone in the right direction for electrical information, and I'm also the one that does most, if not all, of our electrical trainings here in Southern California, and also elsewhere around the country where we sell it. So I can point you in the right direction, or if you're asking for some information or a video of how something works and we don't have it, it's not a big deal to put something together. So I can definitely help with that as well. All right, any other questions here? It looks like we got a couple. Can these types of routes be done in routing without SOLIDWORKS electrical? They can, but it's very time consuming and it's not based off of anything. So traditionally, I'm going to hop back here into my SOLIDWORKS 3D assembly. Traditionally, if I wanted to route off of this connector, I would say, I could go in here to electrical. Let me exit this route here. I would go up here into my electrical tab and I could just say start route and then specify what type of route it is later. That's not that's useful for creating a flattened document, and you can use that to route off of your existing geometry, but there's no wire information. So there's no way that I can tell what's inside there unless I manually specify later, hey, add wires to this route. So it's a process that works really well. If we were doing a simple, I've got a 6-pin connector on one side and it goes to a 4-pin and a 2-pin. Regular electrical routing might be faster, but if you have SOLIDWORKS electrical, it will always be at least as fast, and it's much more useful information because all of that's feeding back into the database. So we can pull all sorts of reports and design rule checks off of that. So it is possible, Scott, to do a lot of the same things. People have done it, but it's the reason why more people don't do it without SOLIDWORKS electrical is it's just so time consuming and there's no way to really check your work. So it's not a design tool as much as a reporting tool or a rendering tool, which SOLIDWORKS electrical is designed as a systems level design tool. Hugo asked another great question about some of the missing wires here. There's basically, I was trying to show not the entire engine harness, and so some of the things that I removed, I didn't re-link back in. So you'll notice like these injector wires should have a green wire coming out, and I just didn't add that back to the harness this morning when I was putting the rest of this together. I can answer any more specific questions about that, anytime you'd like, but yeah, it's not because it's basically a 2D, 3D thing not being linked, like you said. We got another question here, first time being exposed to electrical. If you're a mechanical engineering student and this looks interesting, I highly recommend checking out the content that's available online for SOLIDWORKS electrical, because this is a really interesting product in the sense that it's a SOLIDWORKS product. So everyone says, oh, it's SOLIDWORKS, my mechanical guys use that. Here you go, mechanical guys, route some wires. But there really aren't very many percentage-wise mechanical guys that are on top of this, that are really taking ownership of this. And the electrical guys are generally more interested in doing things like PCB design. So mechatronics or electromechanical would be the area where you definitely need something like this, so robotics or wiring cabinets or anything like that. And there is there's some job security there if you got good at it. So I say definitely check out the information online, and if you've got a student edition of SOLIDWORKS now, check out, see if you can get a student edition of electrical or the newer version, which I think has electrical in it. So fantastic questions here. Again, you're more than welcome to email me with any additional questions here, and I look forward to talking with more of you about electrical as more people see it. So thanks again for coming. All right, we got to say, can we see the car and what was the scanner? We'll do one more. Little thing here. So this is the car. This is a 94 Mazda RX-7 with a 7-liter LS series V8 and a Vortec V7 YSI supercharger. Makes over 1,000 wheel horsepower. It's real fun to drive. And the 3D scanner here is a Creaform HandyScan 700. It's definitely overkill for an application like this. We could have gotten by with a lower end scanner, but this is the one that we have, so it's what I used. The dots you see are for gathering constellation data. So it's a laser scanner, so it doesn't use visible light. It uses red lasers. So the paint is very reflective. So we need to put some of these stickers on so that the scanner can orient the points that it pulls relative to other points that it pulls, because this is handheld. We didn't have to take the car somewhere. I was able to do this from my shop. So as you walk around, just point the scanner at the car. You can see the laptop off over here off to the left, same laptop I'm using right now to give this webinar. You just start seeing it appear in 3D. And it's a really incredible experience. And then we have some other software called Geomagic Design X that is able to then make solid bodies or make surfaces off of that scan data. So we took one with the body panels on, we took another one with the body panels off, and combined those two scans, basically matched up the similar geometry between the two of them, and we're able to get that solid model that we're playing with here in SOLIDWORKS. So great questions, everybody. I appreciate the opportunity to show this. I'm very excited about this tool, obviously. Use it every day. And please shoot me an email if you have any questions and want to chat more. Thanks again for coming.